Welcome to Brain Vision.
Hi, for this question, we're told to repeat the problem in question 22, and the question in 22 was that the angle at point A is, the initial angle is 0 at point A when t is equal to 0, and the initial angular velocity is 0.1 rads per second when t is equal to 0. The acceleration, angular acceleration is 2 rads per second, and in this problem now, 24, our angular acceleration is 2 times the angular velocity. And we want to find the velocity and acceleration at t is equal to 1 second. Alright, so first of all, from this angular acceleration is just 2 times angular velocity, we can substitute this angular acceleration with the omega rather, dt, because the angular acceleration is the change in angular velocity with time, and this is equal to 2w. And if we rearrange this, we bring w down, bring the t up. dw is over w is equal to 2 dt. Now we can integrate this, and that becomes integral of dw over w, and the upper and lower limits will be w and w naught from the initial to the final angular velocity. This is equal to from the initial time, which is 0, to the final time, and 2 dt. And integrating this, we get this will be equal to this. We're pretty much integrating 1 over w, rest dw. So this is going to be ln w, and this will be ln w from w to w naught. I keep saying w, but it's actually omega to omega naught, rather from omega naught to omega, and this is equal to integral of 2, we get 2t, and this is from 0 to t. Solving, we get ln omega naught minus ln omega minus ln omega naught is equal to 2t. And so we can rearrange this to make ln w the subject, and this is equal to 2t plus ln omega naught. And omega will be equal to, so to remove this ln, we raise both sides, we do e raised to the power of both sides, and this becomes e raised to the power of 2t plus ln omega naught altogether. And so we have successfully derived an equation for w. And to find the angular velocity at t equal to 1 second, we simply substitute 1 here. So we have omega is equal to e raised to the power of 2 times 1 plus ln, and omega naught from the question is 0.1. And remember, our angular acceleration was 2w, so this is 2 times e raised to the power of 2 plus ln 0.1. And remember that our angular velocity, the formula for this using integration is d theta dt. And so this is equal to, so this becomes angular velocity dt is equal to d theta, and we can just replace this with the angular velocity we have here and integrate both sides. Integrating this from 0 to t, and this is e raised to the power 2 plus then 0.1 dt, and that's equal to from 0 to theta, because remember the initial angle was 0, d theta. And so integrating this, we get e raised to the power 2 plus ln 0.1 times t within from 0 to t, and we can just substitute the value, so we get e raised to the power 2 plus ln 0.1 times t, and t is 1. Sorry, I forgot to include t here. So let me just clean this. And integrating this will give us 1 over 2 e raised to the power 2 t plus ln 0.1 within constraints of 0 and t. This is equal to theta minus 0, which is theta. And this will be 1 over 2 e 2 plus and remember our time is going to be equal to 1, so let's just put that down here. Our final time is 1 plus 1 ln 0.1 and minus 2 e raised to the power 2 0 plus ln 0.1. So this is just 0, and we're left with ln 0.1, which equals to theta. And we can easily just solve this in the calculator, and we get. So I'm not going to solve it now, so I'm just going to leave it unsolved, so I don't have to approximate. Now, finally, for the velocity, v is equal to the angular velocity times v at a is equal to angular velocity times the radius at a, and the angular velocity we calculated that as e raised to the power of 2 plus ln 0.1 times the radius, which is 200 millimeters, so that's 0.2 meters times 0.2. And our answer as the velocity is 0.1478 meters per second. Now for the acceleration, and this is in two parts, the tangential acceleration and the normal acceleration. For the tangential acceleration, at at a, we're using the formula alpha angular acceleration times radius at a, and this is equal to 2 times e raised to the power 2 plus then 0.1 times 0.2. So, and actually before we go to the angular acceleration, I forgot to finish the velocity. So we need to express this in unit vectors. So this is going to be VA equal to minus 0.1478 sine theta, because let's say this line represents the velocity at 1 second, which is directed here, and our components will be up and left. So I is going to be in the negative x direction and j is in the negative y direction. So to resolve this, this will be 0.2 cos theta and 0.2 sine theta. So for our I, we're using 0.2 sine theta, and for our j, we're using 0.2 cos theta. Times sine theta I plus 0.1478 cos theta j. And calculating this, we get, so this theta we're using is this we got here. So I'm just going to do that in the calculator and come back. So the answer is minus 0.0464 I plus 0.14 j. Now for the acceleration, tangential acceleration, we go to alpha r a is equal to 2 times the angular velocity, which is 0.2956 meters per second squared. And the tangential acceleration and tangential velocity are in the same direction at this point, so we can also multiply by the same thing multiplied by with the velocity. This is going to be, the component is going to be minus 0.1478 sine theta I plus 0.1478 cos theta j, which is equal to, and sorry, I actually put the wrong values here. This should be minus 0.2956, which is 0.2956. This is for tangential acceleration. Now for a normal acceleration at a is equal to v squared over r, and from the v we have equal to 0.1478 squared over the radius, which is 0.2. That is equal to 0.10922 meters per second squared. And if we look at our diagram again, for normal acceleration, it's going to be directed towards the center of the circle, so this direction, and the components will be left and down. And for the left, this is minus I, this is minus j, and for the I we have cos, for the j we have sine. So this will be equal to 0.10922 minus cos theta I minus 0.10922 sine theta j. And our final answer is going to come down to, for the acceleration, we just need to add the tangential and the normal, a t plus a n, and after calculating all of that, you get 0.0 minus 0.1965 I plus 0.246 J. And this is in meters per second squared. And that was a long one, but we're done. And for the velocities in meters per second. Alright.